Hello. Well, you don't see this in Singapore, but in many countries, you see these satellite dishes on their rooftops. So these people are probably using satellite TV. Now, have you noticed that these satellite dishes usually point in the same direction? Why is that so? Well, probably they are aiming at the same satellite in the sky. But has it ever occurred to you that they didn't have to adjust the direction of the satellite dishes? Because don't the satellites move across the sky? Yes, most of them do. As you can see here, the satellite is traveling to different parts of the world. It kind of scans the Earth, as it orbits the Earth. So most satellite dishes will leave such a ground trace. So not only are they going eastward, because they are circling the Earth once every 90 minutes, whereas the Earth takes how long? 24 hours, to do one round. And not only that, it's also going up and down, right? It's going northward and southward and northward and southward. So if you want your satellite to be stationary when viewed from the Earth, then an orbit that's inclined to the equator is not a good one, At the very least, you should use an equatorial orbit. But this is still not good enough, So even though now you stay above the equator, but you still be racing across the sky because your orbital period is too short. So what should we do? Well, we have to park our satellite higher up where the orbital period is lower. So what is this altitude that's needed? The calculation is very straightforward. So first, let's calculate the required angular velocity. It should be 2 pi divided by 24 times 60 times 60 because the Earth takes 24 hours to do one round. So we want our angular velocity to match the rotational speed of the Earth. So turns out this is the required angular velocity if we want our satellite to match the Earth's rotation. Next, remember we are relying on the Earth's pull to provide the required centripetal force. So we can write gml over r squared is equal to mr omega squared. As usual, the mass of the satellite gets cancelled off. Plug in all the numbers, especially omega. Omega needs to be this much. So it turns out the geostationary orbit has an orbital radius of 42,000 kilometers. Now do you understand why we spend so much effort and energy and money to park a satellite so far away above the Earth's surface? We do this so that our satellites appear stationary from the Earth. And that's a very attractive feature if you are a satellite that's broadcasting TV signals to all your audiences. You don't want your audiences to have to continuously adjust their satellite dishes just to track your position in the sky. Alright, that's all. Ta-ta!